In example 2, we're going to use a bar chart. Okay, and we've already talked about how a bar chart is really useful for doing discrete data as well as uh, categorical data. And so this particular bar chart shows the number of days that it snows each month. So let's first figure out rather, the total number of snow days that we had in this particular winter. So in January we have 2 snow days, February it's 6 snow days, February is 14, and March is 3. Okay, so if I add those numbers together, 2 plus 6 plus 14 plus 3, that gives me 25. So there are 25 snow days in that particular uh, winter. Okay, so based on the data, in what month would you expect the most number of snow days for part B? It says, well, if I look at this bar chart, clearly February has significantly more snow days, so perhaps on average, February has more. So I would expect that the most number of snow days that I would get next year would probably be in February. So why was this graph displayed as a bar graph instead of a pie chart? Because a pie chart can also be used to describe both categorical and discrete data. Well, in this particular instance, I believe that we probably would have done this as a pie, or as a bar graph rather, because it actually goes in chronological order. Okay, it follows the timeline of winter: December, January, February, March. Okay, and so that just makes it very easy to read and for people to understand. Okay, so it follows the winter timeline. Okay, and because it follows the winter timeline, it makes it easier to read. Okay, so what percentage of snowy days falls in the month of December? Well, in December there's 2. Okay, there's 2 snowy days in December, and the total number of snowy days is 25. We determined that right off the bat. Okay, so 2 divided by 25, that is 0.08, and 0.08 as a percentage is 8%. Okay, as I said, you could also have represented this bar graph as a pie graph, and that would have been equally valid. So let's imagine for a second that we were asked to create a pie chart based on the information in the bar. So calculate the size in degrees of the number of the section that would represent the number of snow days in December. Okay, so a couple of things we need to know. In a pie charts are always circles. The total number of degrees in a circle is 365 degrees. Okay, now 365 degrees represents 100% of the pie chart. So if I want to figure out what 1% represents, I need to take 360 degrees represented by that 100%, and that's going to give me 3.6. So that means that every single percentage is represented by 3.6 degrees. So if I want to figure out the number of degrees that would be represented by 8%, or the December number, then what I do is I take 8% times 3.6 degrees, okay, which is going to equal 28.8 degrees. Okay, so 28.8 degrees, and you might want to round that up to 29 degrees. Okay, so bar charts are really useful for both discrete and categorical data, and you can flip between them, between bar charts and pie graphs.